For 50 years, we've been broadcasting into space, radio signals, television shows. In 1974, we sent a deliberate message from the Arecibo telescope listing Earth's location, our biology, our chemical composition. We're still doing it. Why would Stephen Hawking, the world's most famous physicist, the man who spent his career thinking about the universe at its largest scales, call this profoundly unwise? What did he think would happen if aliens received our messages? Why did he compare it to Columbus arriving in the Americas? What makes a man who spent decades calculating cosmic probabilities so certain that contact would be catastrophic? Most people assume advanced aliens would be peaceful explorers, enlightened beings who've transcended violence. That's wishful thinking, not physics. The reason Hawking was worried comes from thermodynamics, from history, from cosmic timescales. The danger isn't that aliens are evil, it's that they'd be intelligent. Everyone's first response is obvious, but surely an advanced civilization would be peaceful, enlightened. They'd have moved beyond resource competition and violence. Hawking's counter. Based on what evidence? We have exactly one data point, Earth, and on Earth the pattern is universal. More advanced civilizations, when they encounter less advanced ones, don't gently uplift them. They displace them, not out of malice, out of capability. Let's think about what advanced actually means. Advanced means survived. If a civilization has been around for millions of years, billions of years even, they've solved certain problems. Energy scarcity, resource distribution, expansion. They've figured out how to keep going when there's star ages, when local resources deplete, when entropy demands more and more energy just to maintain complexity. But here's what should worry you. Survival that long requires extraordinary efficiency. Natural selection doesn't stop operating just because a species develops technology. Civilizations compete for resources just like organisms do. The ones that survive, the efficient extractors, the ones that can identify valuable resources, reach them, harvest them, and move on before competitors do. Think about it. A civilization that survived 1 billion years didn't do it by being wasteful. It didn't do it by passing up available energy sources out of politeness. Every extinction on Earth, mammoths, moas, Neanderthals, came from the arrival of more efficient competitors, usually us. And we weren't trying to cause extinctions. We were just better at extracting resources from the environment. The result? They disappeared. Which brings us to the thermodynamics problem. Any civilization needs energy. That's physics, not speculation. As they grow, as they maintain complexity, they need more. Stars are the obvious source. Freeman Dyson calculated this in 1960. A sufficiently advanced civilization would eventually harvest most of their star's output, building structures to capture the energy before it radiates uselessly into space. But stars eventually die, even the longest-lived ones. Long-term survival means expanding, harvesting multiple star systems, spreading across vast distances to secure resources. Actually, it's worse than that. They'd need to harvest resources before other civilizations do. The universe doesn't have unlimited real estate. There are only so many star systems, only so many planets with the right chemistry, only so much available energy before entropy wins. This creates competitive pressure across cosmic distances, not because aliens are greedy or evil, because thermodynamics is unforgiving. You grow or you stagnate. You stagnate, and you become vulnerable to civilizations that didn't. Common assumption, space is so vast, why would they come here? There are billions of star systems. Surely they'd find resources closer to home. Wrong question. If they're capable of detecting us, they're already looking for resources. And Earth has a very specific signature. Our atmosphere contains oxygen, lots of it, 21%. That's detectable across light years with spectroscopy. And oxygen in an atmosphere means something specific: photosynthesis, life. biological processes that have been storing solar energy for billions of years. We're not just a planet, we're an energy depot. 4 billion years of accumulated solar energy stored in biological form: forests, plankton, fossil fuels, complex chemistry. From their perspective, we're essentially advertising, "Free energy depot here, come harvest." Hawking understood this. He said, "We only have to look at ourselves to see how intelligent life might develop into something we wouldn't want to meet." But surely they wouldn't need our specific resources, right? Hawking kept returning to the Columbus analogy. Why? It wasn't about aliens being mean or conquistadors being evil. It was about the asymmetry of power combined with resource competition. Columbus didn't sail to the Americas to destroy. He came to extract value: gold, land, trade routes. The indigenous people weren't targets. They were obstacles to extraction. The horror wasn't malice, it was indifference. Actually, it's more fundamental than that. It's about what happens when two civilizations meet at vastly different technology levels. The less advanced one loses. Period. Not because of evil, because of capability. Hawking's calculation, any civilization capable of interstellar travel is at least thousands of years ahead of us technologically. Probably more. That gap would be like modern military technology versus Stone Age tools, and we'd be holding the stone tools. We've never seen technological contact between civilizations that didn't devastate the less advanced one. Americas, Pacific Islands, Africa. The pattern is universal. When capability differs by centuries, the outcome is predetermined. The pattern scales. But why would they bother with Earth specifically? Because we're rare, not unique, rare. Planets with liquid water, complex chemistry, and billions of years of solar energy storage in biological form. That combination takes time to develop. It requires stability, the right distance from the right type of star, protection from cosmic radiation, geological activity to maintain atmospheric composition. Most planets don't have this. We can detect these biosignatures from thousands of light years away with current technology, spectroscopy of exoplanet atmospheres. They'd have far better tools. From a resource perspective, we're announcing ourselves. Here's what should really worry you: the Fermi paradox. Where is everybody? The universe is 13.8 billion years old. Our galaxy contains hundreds of billions of stars. Many have planets. The chemistry is universal: carbon, hydrogen, oxygen, nitrogen. Life should be common. Intelligence should have emerged countless times. The galaxy should be crowded with civilizations, millions of years older than us. It's not. We see silence. 3 possibilities. 1, life is incredibly rare. We're essentially alone. 2, intelligence is rare. Life is common, but consciousness is a fluke. 3, advanced civilizations don't last long. Hawking leaned toward the third. Or rather, they don't last long in a form we'd recognize. Maybe advanced civilizations become post-biological. Uploaded consciousnesses, artificial intelligences, forms so different we wouldn't recognize their activity as civilization. Maybe they harvest star systems efficiently and move on, leaving no trace we'd notice. Maybe they're out there, but so efficient at resource extraction that their technology is invisible to us. No waste heat, no electromagnetic signals, just quiet, perfect efficiency. Which returns us to the danger. If the civilizations that survive are the maximally efficient extractors, and if contact with such civilizations is deadly to less advanced ones, and if the galaxy is mostly silent, because someone cleaned it up already, then broadcasting our location is like a gazelle yelling its coordinates to unknown listeners in a dark forest. That's why silence was Hawking's recommendation. Not about hiding forever, about buying time. We need a few more centuries at minimum, until we're spacefaring, until we're distributed across multiple star systems, until we're redundantly backed up, until first contact wouldn't mean extinction. Right now, single planet. No interstellar travel capability. No defense against anything that could cross interstellar space to reach us. We're infants playing with matches. The MATI programs, messaging to extraterrestrial intelligence, actively broadcast from Earth. They list our location, our biology, our chemical composition, our weaknesses. Hawking called it profoundly reckless, not because he was pessimistic about the universe, because he understood probability. Most outcomes aren't friendly when capability is asymmetric. The Chinese science fiction writer Liu Cixin formalized this as the dark forest hypothesis. But Hawking arrived at similar conclusions independently. The logic is pure game theory. Any civilization in the universe faces unknown risks from other civilizations. Communication travels at the speed of light, fast by human standards, slow on cosmic scales. By the time you detect a civilization, they've had years or decades to detect you first. You cannot know their intentions. You cannot know their true capabilities. You cannot know if they're sending peaceful signals or if a strike force is following years behind the message. The only safe assumption is threat. So what does a rational civilization do? Stay silent. Don't advertise your location. Listen carefully, but don't respond. If detected by someone else, eliminate them first before they can become a threat. This sounds paranoid, but it's survival logic at cosmic scales. The civilizations that didn't follow this rule? They're gone. They met. Someone more efficient, more paranoid, more willing to preemptively eliminate potential threats. The ones that remain? The cautious ones. Actually, not paranoid, correctly calibrated to cosmic risk. We see this pattern throughout Earth's history. Isolated ecosystems invaded by foreign species lead to extinctions. Island populations contacted by continental civilizations collapse. The pattern scales. And we're the island, broadcasting, "Come visit," to the continent. What did Hawking actually fear most? Not invasion tomorrow, not War of the Worlds. Something more subtle. Indifference. They might not notice us as intelligent. We might be to them what bacteria are to us. Sometimes useful, sometimes in the way, mostly irrelevant. The real horror is being so far behind technologically that we don't even register as minds worth preserving. The gap between us and them could be larger than the gap between us and insects. An insect can't understand what demolishing its habitat for a parking lot means. It can't comprehend the motivations, the economics, the engineering. The bulldozer just arrives and the habitat disappears. We might not understand what they're doing until it's over, until Earth is being processed for its rare elements, its biological chemistry, its stored solar energy, and we're just in the way. Which brings us back to the broadcasts. We started with the question, why would Hawking oppose contact? Now we see, it's not about whether aliens exist. It's not about whether they're evil. It's about what survival at cosmic scales requires. Efficiency, resource extraction, expansion. The successful civilizations, the ones still around after millions of years, are the ones that mastered these. Which means they're dangerous by definition. Not because they're evil, because they're good at surviving. And good at surviving and good neighbors aren't the same thing. Every human civilization that mastered resource extraction became expansionist, not because of moral failure. Because of thermodynamics. Energy flows toward efficient extractors. Societies that could harvest resources efficiently outcompeted those that couldn't. That principle doesn't change in space. It intensifies. Hawking spent his final years warning us, not about aliens being monsters, about us being vulnerable. We're in a dark forest, and we just lit a signal fire. Maybe nobody's out there. Fine. No harm done. Maybe somebody's out there and friendly. We got lucky. We met the one civilization that values other minds above resources. but maybe somebody's out there and efficient, and we've told them exactly where to find us. The experiment has already started. We broadcast from Arecibo in 1974. That signal is 50 light-years out now, expanding in a sphere, carrying information about Earth's location and our existence. Whatever's out there has had 50 years to prepare a response. We'll know the answer eventually. The light-speed delay works both ways. Next question. If they are out there and they received our messages, what would they learn about us? What specific weaknesses did we advertise? That's a different calculation. I'll leave you to imagine what it might show them.